Okay. So we'll start with the second. So first exercise, what we have learned is the basic formula for integrals, right? So we have learned that thing. Just a minute, wait. Okay. So we have learned the basics of integrals. So I hope you guys understood that for the integrals, the formula is nothing but the answer for the derivatives. So whatever you get as the answer in the derivative, if that becomes the question, then you will get the reverse function as the antiderivative. Right. So from the next exercise, what we are going to do is, we are going to see how are we going to integrate different functions available. Okay. And what are all the methods which we can follow for integrating them. For example, before I start the exercise, let's try to understand. If I ask you a question like this, what is integral of sin x dx? Your answer is?
Minus cos x.
Minus cos x plus c, right? If I ask you a question like integral of sin 2x dx, what will your answer be? So using the method of inspection, we have found what it is, right? Do you remember what it is? So what is it? So derivative of which function will come out as sin 2x? So derivative of which function is sin?
Cos.
Cos x.
Minus cos, right? Because I want plus. So minus cos of, I have the angle as 2x. So minus cos 2x. Is it what I'm going to write? So what is the derivative of minus cos 2x? It will be 2 sin 2x, right? So when this goes to the other side, derivative of minus cos 2x will be equal to 2 sin 2x into dx. So integrating on both the sides, what will happen is, this side you will get minus cos 2x is equal to 2.
Sir, are you sharing the screen?
I didn't share, I'm sorry.
Where?
Yeah, I didn't. Yeah, sorry, I missed it. Now is it visible?
Yes, sir.
Yes, sir.
Yeah. So minus cos 2x is equal to 2 into integral of sin 2x dx. So integral of sin 2x dx will be equal to minus cos 2x divided by 2 plus c. This we discussed in the previous class, right? So what happens is, when you have sin 2x, you get a 2 in the denominator. Like when you differentiate sin 2x, you get the 2, the one which is inside the function, as the product. You get it as 2 cos 2x. Whereas when you integrate it, you get it as a denominator. This concept, I remember discussing it in the previous class. I hope it is clear. Right?
Yes, sir.
Now the question, this one we found using the method of inspection. Okay. Method of inspection is not a standard method because you're using a trial and error method. What if the function is so complicated? Right? If I put something like this, integral of sine of 2 log x dx. If I put something like this, it will become complicated. You cannot use a method of inspection, right? Right, it becomes a composite function. You know what is a composite function? It is f of g of x. Right, it becomes a composite function which is slightly complicated, at least in this case, where we cannot proceed. So in this, so depending on the scenario, what we are going to do is we are going to use different methods that are there in the integration process. So one of such methods is called as integration using the process of substitution. I'll explain what it is. So the topic is about methods of integration. The first method that we are going to see is 7.2 and 7.3 are completely based on the method of integration by substitution. The second one is integration using partial fractions. And the third one is a concept called as integration by parts. This is something similar to the product rule that you have learned in derivatives. So we will see one by one. Let's not hurry. We will see one by one. So I'm going to start with the method integration by the process of substitution. Okay. So what we are going to do is, so the first process, integration by substitution. Suppose I have a question like this, integral of f of x dx, right? So you can transform it into an other form. So here if I ask you, the function is dependent on which quantity? What is the independent variable? I can put the question like this. If I give you a question like integral of f of x dx, you're integrating the function with respect to what?
X.
Obviously with respect to x. So it is not necessary that every question has to be with respect to x only. What you can do is you can assign the variable x to some other variable t and convert it to some other function g of t, and you can integrate it with respect to g of t also. That is, you can change it as something like this. When you look at it as a generic term, it looks a little complicated, but I'll tell you how to use it. Okay. So what they are doing is, observe. So I have the function f of x, integral of f of x dx. It can be transformed into other function by changing the independent variable. So what is the independent variable being substituted as? If you substitute it as g of t, then what will happen to I is equal to integral of f of x dx? Right, this is a question.
Of g of t
Into, wait, I'll show you. So observe carefully. That's what we are going to do for all the problems. I'll tell you when to use it also, you'll understand it. So the question is integral of f of d of x, f of x d of x. If I put x is equal to g of t, what is the meaning of this? I am assigning the independent variable to some other variable t. That is the meaning, right? Then my question is, if I substitute it here, what are all the changes that will happen? I'll have it as integral of f of, in the place of x, I will substitute it as g of t.
Yeah.
I hope it is clear till this step. But
Yes, sir.
I have dx also. What do I do with it? That is what I need to understand. So whenever you're using the substitution method, the first step is assigning the variable to some other variable, the independent variable, that is x to some other variable. Then differentiate on both the sides. So when I say differentiate on both the sides, the immediate question you should ask me is differentiate with respect to what? So what should I differentiate? So I need to differentiate the left-hand side with respect to what? With respect to the
dt.
function that is with respect to t. So if I do that, dx by dt will be equal to g dash of t. I hope you're able to understand this. So which implies dx will be equal to g dash of t into dt. So what will f of x, integral of f of x dx get transformed to? It will get transformed to a function like integral of f of x, integral of f of g of t into, in the place of dx, I'm going to write it as g dash of t dt. Okay, so this is the one which we are going to integrate. Means, why do we do this is to convert it into a simple form, because the basic formula that we know have been discussed here. What are all the basic formula that we know? I've told you in the previous class. 1 minute. So these formula are there, right? These are all the basic form. So if the function is slightly complicated, you will try to substitute the variable in such a way that you're able to bring it to a simple form and then integrate. So that is what this integration by substitution method is. So for example, I'll start with a question like this. So I asked you a question of integral of sine 2x dx is equal to, we got the answer as minus cos 2x divided by 2 plus c. Now what I'm going to do is I proved this using the method of inspection, but I'm going to use substitution method. Here I cannot integrate it directly because I have the formula only for integral of sine x dx, that is minus cos x plus c. Had it been like very simple, like integral of sine 2x dx is equal to minus cos 2x plus c, I could have done it. But what is that is happening? You are getting a 2 in the denominator. We don't know why the 2 is coming, right? So for that, what I'm going to do is observe. So this is the question. So on the LHS, I will put 2x is equal to t. Means wherever I see 2x, I will replace it with t. Okay, which implies, what should I do immediately? Differentiate on both the sides. You can directly write this step. 2 into derivative of x is dx is equal to derivative of t is dt. I hope it is clear. You would have understood why it has come. Because if I differentiate with dt on both the sides, 2 into dx by dt is 1. This dt goes to the other side. So now onwards, you can directly write it as 2 into dx is equal to dt. So what is the value of dx? Dx is equal to dt divided by 2. So what will the question get transformed to? Integral of sine 2x dx can be written as integral of sine of, in the place of 2x, I can write it as t. In the place of dx, I can write it as dt by 2. So half into integral of sine t dt. So what is integral of sine?
Minus cos.
minus cos t plus c. But what is c t?
2x.
Cos 2x.
So that is why you are getting a 2 in the denominator. I hope you guys are able to understand.
Yes, sir.
Yes.
Yes, sir.
So this is the method of substitution. Okay. So this is a very, very, very basic problem. Okay, you can make a note of this. Then we can start doing the exercise. I'll tell you how to think when a question comes.
So,
Yeah, tell me.
in each problem, how do we know which variable to take? Which variable?
I will tell you. That's what I'm saying. You first note it down. I will tell you. If I give you examples, only you can understand. That's why I told. This is a very basic problem. You make a note of it. By the end of the session, you'll have a clarity of it. Trust me. So let me know once you're done.
Done, sir.
Done?
Yes,
Done,
sir.
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 Yeah. This one. Huh? Yeah. So we'll see the questions. The example number 5 is integrate the following functions with respect to x. So you see with respect to x. So what is the question going to be? So it is like this. No, see. So what is the question? Integral of sine mx dx. That is the meaning. So what do I do? Just now I told you. Instead of 2, what do you have?
MX.
mx.
Right. So what is it we need to do? Put
M is equal to T.
mx equal to t, which implies m into dx is equal to dt. Right. So integral of sine into, in the place of mx, I'm going to write it as t. In the place of dx, I will write it as dt divided by m. So that will be 1 by m into integral of sine t dt. This will be 1 by m into minus cos t plus c. Plus c can be written separately also. Minus cos t plus c. So 1 by m into minus cos of t is what? Mx. Yes, that is the answer. Okay. So we follow all these steps. Next. So if you do the next one, the question is integral of 2x into x square plus 1 dx. See, there is a problem where you can think two methods. Okay. So one method is what
Sir,
you
is
can
it
do
not
is
2x into sine of x square plus 1?
is the sine of x square plus 1. Okay. Then it's then you have to go with substitution. So 2x into sine of x square plus 1 dx. Now, if you observe one thing, whenever there is a condition where you need to apply substitution, see 90% of the problem in integration are solved using only substitution method. This is an exercise only for you to give an understanding of. So this exercise will contain only problem based on substitution. But when you go for the other exercises, no, one of the steps that we include in the whole process of solving a problem will be a substitution method. Okay, so that time you need to understand. So when to use substitution is, for example, if I look at this question, I have an algebraic function and a trigonometric function. But if I look at the trigonometric function, it is not in a standard form. What do you mean by standard form? So for me, trigonometric function, I can say it as standard form if I have only sine x. That is the easiest thing for me. I don't have something like sine x. Rather, what do I have? I have x square plus 1. So if you observe this 2x, okay. So if you observe the algebraic function has come as the result of derivative of x square plus 1. This logic we know because if you differentiate a second degree function, you get a first degree function. So what am I supposed to substitute as t in this problem? Put x square plus 1 as t. Okay. If I do this, what do I get? If I differentiate on both, so whenever I put this in place, I'm differentiating on both the sides. So I'll not tell it every time. So 2x into dx. I'm applying chain rule. 2x into dx plus derivative of 1 is going to be 0 is equal to, what is the derivative of t? It is dt. Right? I hope this is clear. So 2x into dx, wherever I find this, I can replace it with dt. Wherever I find x square plus 1, I can replace it with t. So if you look at this question, 2x into dx, I can write it as dt. So the question gets transformed as sine of x square plus 1 is sine t into dt. So what will be the answer? Minus cos t plus c. But what is t?
X square plus 1.
X square plus 1.
So minus cos of x square plus 1 plus c. So this is the final answer. I hope you guys understood this.
Yes, sir.
Yeah.
Sir,
Yeah, tell me.
can you explain how the second step came, sir? The 2x dx equal to dt.
Differentiating on both sides. So x square plus 1.
Okay, sir.
Okay. So 2x into, I'll explain it in a different website. 2x into dx by dt, chain rule, plus derivative of 1 is 0 is equal to derivative of t is 1. So 2x into dx will be equal to dt. That is what I did. So instead of writing these many steps, I directly went to this.
Thank you, sir.
So if you're clear with these two, we can go to the next one. So if anybody wants to make a note, let me know. Okay. So third one, integral of tan power 4 root x into secant square root x the whole divided by root x dx. So here, which variable is looking complicated?
Root x.
Root
Yeah,
x.
So if you see root x, okay, this should run in your mind. What is the derivative of root x?
1 by 2.
1 by 2 root
1
x.
by 2
1
root
by
x.
2 root x. So derivative of root x will give you 1 by 2 root x. No, so you have 1 by root x in the denominator. So there is a high possibility that you, when you substitute root x as t, dx by root x will come out as dt. Okay. Now what I'm trying to explain is, put root x is equal to t, which implies 1 by 2 root x into, you should always follow chain rule, into dx will be equal to
dt.
dt. Okay. So dx divided by root x. So dx divided by root x will be equal to
dt.
2 dt.
2 is there, no?
Okay,
2
2
dt.
dt.
So the question will become integral of tan power 4. Instead of root x, I can write it as t into secant square t the whole divided by no whole division. The divided by will go because I have dx by root x. So dx by root x, I can replace it with 2 times dt. So what will come out of the integral? So 2 will come out, 2 into integral of tan power 4t into secant square t dt. Okay. This is clear till this step.
Yes, sir.
Okay.
Yes,
Now what?
sir.
Now what I'm going to do is, I'm actually using double substitution method. Observe what I'm going to do. There is another way to solve this problem also, that also I'll tell you. So what the method, don't look at the solution now. So the method that I'm following now, I'm going to use double substitution. Why I'm going to use double substitution is, it is difficult for me to solve this, because I don't have a formula for what is tan power 4t into secant square t. I should either have only secant square t, only maybe tan square t, something like that. But I have a combination of both. But if you observe these two, which one can I substitute as some other variable so that one becomes the derivative of other? So if you observe, secant square is there, right? Secant square is a derivative of which function?
Tan.
Tan, right?
And
So what I can do is put tan t is equal to z. Are you guys able to understand? Tan t as z. So if I put tan t as z, then what do I get? Secant square t into dt will be equal to dz. I follow chain rule, nothing else outside that. So secant square t into dt, I'm going to replace it with dz. Wherever I find tan t, I will replace it with z. So what will happen to the question? 2 into integral of, can someone tell me what? Z power 4 into
dz.
dz.
So 2 into, what is the integral of z power, integral of x power 4 dx?
Z power 5 by
Z power 5 by 5.
dz. Let's see.
So this will become 2 times. See, look at the way I'm going to substitute the values back. See, this 5 I've taken out of the value. So z power 5, z is what? Tan t. So tan power 5t plus c. But my question was not in terms of t. So what should I do? 2 by 5 into?
Tan power 5 root x
root x.
plus c.
That's it. So tan power 5 root x plus c. This is going to be my final answer. Okay. So I hope this is clear. So I've done double substitution. Again, I've substituted back what is the original value in it. If there is anyone having a doubt, please let me know. So if
Sir,
you're
is
done,
there any other method we can solve?
I'll tell you. Yeah, there is another method.
Yes, sir.
Done, sir.
Done?
1 minute, sir.
Yeah, I can. Let me know once you're done.
Yes,
Just
sir,
a
done,
minute.
sir.
I'll add some empty page. So what is the question? Integral of tan power 4 root x into secant square root x divided by root x into dx. Okay. Now what you can do is, this root x, you can have it as t in your mind itself. Then what you can do is, wherever you have secant square and a combination of tan, the tan can have any power. But what you should have is, you should have only secant square of something. If you have something like this, then you can put the tan of something as t. Am I clear? I'm repeating it again. You can make a note of it. Integral of tan power m into x into secant. If at all you this 2, you make a clear note of it. I'm repeating it. Integral of tan power mx into secant square x dx. Whenever you have something like this, the idea that should come to your mind is, put tan x is equal to t. So here, instead of x, I have root x. Okay, tan into root x is equal to t. Then what will happen is, differentiating on both the sides, secant square root x into derivative of root x is 1 by 2 root x dx is equal to dt. Right? So this will come out like this. So secant square root x into dx divided by root x is equal to 2 times dt. Is it clear? So what I have done here is secant square root x divided by root x into dx. I called it as 2 dt. Then what will the question get transformed to? It will get transformed to 2 power 4 into 2 dt. So 2 into, what is the value of integral of t power 4 dt?
3 power 5 by 4.
Same thing again. So 2 into t power 5 divided by 5 plus c. So 2 by 5 into t power 5 is how much? T is nothing but tan root x. So tan power 5 into root x plus c. So we'll get the same answer. Right? 2 by 5 into tan power 5 root x. 2 by 5 into tan power 5 root x plus. I hope this is clear. So you can use any of the methods. As you practice more problems, we'll get experience of what to substitute. Okay, don't worry.
That's it.
Yeah. Go to the next one. So what is the next question? So derivative of, here observe, we have derivative of tan inverse x as 1 by 1 plus x square. So you remember this, right? Okay. So what is the page number? Derivative of tan inverse. See, for example, next I'm going to show you some derivations. What is the next question that is given? So fourth one is sine of tan inverse of x divided by 1 plus x square. So fourth one is sine of tan inverse of x divided by 1 plus x square into dx. You guys tell me, what should I substitute as t? So how you can visualize?
Tan
Yeah.
inverse of x.
Yes. How you can visualize the question is sine inverse of x into 1 by 1 plus x square into dx. Write it in this form. Now think, derivative of which function is 1 by 1 plus x square? And one more important point in integration is you should always see to it that the denominator is eliminated. There's a very important rule with respect to integration. So you should make sure that you don't have denominator. Okay. So if I put tan inverse x is equal to t in this problem, then 1 by 1 plus x square into dx will be equal to dt. Am I right? So this will become integral of sine of tan inverse of x is t into dx divided by 1 plus x square. I can read it as
dt.
So minus cos t plus c. So that will be minus cos of t is nothing but tan inverse of x plus c. That's it. Done?
Yes, sir.
1 minute, sir.
Yeah.
Done.
Yeah. So this we are done. Now we are going to see the next set of formulae. Okay. The first formula that we are going to see is integral of tan x. What is the integral of tan x? Till now we don't have a formula. Again, don't get confused. Integral of tan x is not secant square x. Derivative of tan x is secant square x. So integral of tan x, what we are supposed to do is this. I can write it as integral of tan x can be written as sin x divided by cos x into dx. Right. So as I told you in the previous case, your work is to eliminate the denominator. Okay. So here, if you observe this question, this particular part, how to use the substitution method here is, I know that the derivative of sine is going to be cos, and the derivative of cos will give you sine. I'm not concerned about that minus sign. Okay. So I'm repeating it again. Derivative of sine is going to give you cos. Derivative of cos will give you sine in some form. Okay. Now the question is, which one should I substitute as t? So keeping one important point, to eliminate the denominator, I need to substitute cos x as t, because when I substitute something as t, what should I get in the numerator? When I differentiate, I get a dx. Right? Every problem you would have seen by now. Everywhere you get a dx. Right? So the dx will be a part of the numerator. If that should happen, I should substitute the denominator in this question is equal to t. Minus sin x into dx will be equal to, sorry,
Your voice is breaking.
Yes, sir. Your voice is breaking.
now
Sir.
is it better? Now is it better?
Yeah, sir. Now
Yes, sir.
it's better. Sir.
Yeah. So what I was trying to say is, I hope you guys understood which one how you can think. Derivative of sin is cos, derivative of cos is sin. So when you think like that, I will choose to substitute derivative of cos x as t, because when I differentiate cos x, I get sin x into dx. So where is sin x into dx? It is present in the numerator. Whereas if I substitute sin x as t, then what is the problem I will face? I get cos x into dx. Here cos x is in the denominator, whereas dx is in the numerator. So that is the reason I chose cos x to be t. Then minus sin x into dx will be equal to dt. So what is sin x into dx? It will be minus dt. So integral of minus dt divided by derivative of, instead of cos x, I can write it as t. So minus sign if I take out, derivative of, integral of 1 by t is log of mod t. Log of mod x, derivative of 1 by x is log of mod x. So this is nothing but log of, you know this principle, right? So a log x can be written as log of x power a. Do you guys know this?
Yes, sir.
Yes, sir.
So it's a property, right? So this minus sign will go this side. So it will become log of mod t to the power of minus 1. Okay. So it will become log of 1 by t. Am I right? So this will be log of mod of 1 divided by, what is the value of t? Cos x. But what is 1 by cos x?
Secant.
Secant.
So that's why the formula for derivative of tan x is log of secant x plus c. Okay. So you need not do all these steps again and again. I've shown you the proof. You have to remember this. This formula is applied in many other problems. It is log of mod of secant x plus c. Okay. So once you're done with this, try to find out what will be the integral of cot x dx.
Sir,
Log sin x plus c.
sin x plus
The
c.
So
log
mod of sin
sin
x
x.
plus c.
What?
Log sin x plus c. So I can write it as cos x divided by sin x. You will put sin x equal to t, which implies cos x dx will be equal to dt. So integral of dt divided by t will give you log t plus c. So log of mod sin x plus c. That's right. So this is another formula. So you guys got it? Right. Next we will see what is the formula for integral of secant x dx. See, observe. So I don't know the number, I'm just writing it as 3. Okay, but you make a clear note of it. The question is integral of secant x dx. So what is the integral with respect to secant that we know? We know the integral of secant square. Right, but here it is not square, it is power 1. So what do I do to get that? So if I have to convert it to a known integral of any format, then what should I need? What do I need? Then I need to multiply and divide with secant x. Right? So there was a problem. You remember I told you just now, integral of tan power mx into secant square x dx. If you have something like this, then you always have the advantage of putting tan x as t and then proceeding. Right? In a similar way, if you observe, I only have secant. If I make it secant square also, I'm going to have a secant x in the denominator. So to make that secant square come, I need a tan. So what we will do here is, you will multiply and divide the function with secant x plus tan x. Okay. Now observe what I'm going to do is integral of secant x into secant x plus tan x, the whole divided by secant x plus tan x. So if I observe the numerator, what is going to happen? It is secant square x plus secant x tan x, the whole divided by secant x plus tan x dx. Right? Now observe, if I substitute the denominator, again the main process of integration is to eliminate the denominator. If I substitute the denominator as t, then what do I get the numerator as? Derivative of secant x is secant x tan x, because derivative of tan x, secant square x into chain rule dx is equal to what you have on the right hand side. You have a dt. So secant square x plus secant x tan x into dx, I can replace it with dt. And secant x plus tan x, I can replace it with t. So this will be log mod t plus. So log of what do I have inside?
Secant x plus tan x.
So that is the answer. This also has to be remembered.
Sir, how dt came? We having secant x now.
Where secant?
Sir,
I
how
wrote,
does dt came?
oh, observe, no, secant square x plus secant x tan x, the whole multiplied with dx is dt. Secant x tan x
Okay, sir.
plus, yeah. Done. So if you're done with this, so the next formula that you're going to see is for integral of cosecant x dx is equal to. So this will be, so again you don't have the formula for cosecant. So for you to have cosecant, see for example, what are the counterparts of secant square? So whenever you have secant square, you need a tan along with it, so that you can substitute tan as t and then proceed. Similarly, cosecant means you need a
Cot.
Cot.
right. So if you need a cot, what we can do is multiply and divide with cosecant x minus cot x. It is plus. You can do cosecant x plus cot x. What is the derivative of cot? It is minus cosecant square. Derivative of cosecant is minus cosecant cot x. Yeah, you can multiply and divide it with cosecant x cot x. Then you get it as integral of cosecant x into cosecant x plus cot x, the whole divided by cosecant x plus cot x dx. Now what are we supposed to do? You people tell me.
T is equal to cosecant x plus cot x.
Yes, denominator is t. You put it as t, then what do you get as numerator? Solve it, you will get the answer. Try it out. So cosecant x plus cot x, if I substitute as t, minus cosecant x cot x minus cosecant square x, the whole dx is equal to dt. Right? So cosecant x cot x plus cosecant square x, the whole dx will be equal to minus dt. So what will happen to the numerator? Numerator is cosecant square x plus cosecant x cot x. So it will become integral of minus dt divided by t. So it will be minus integral of log of mod t plus c. So minus is there, it will go as a power. So I will have log of 1 by plus c. That is log of 1 by cosecant x plus cot x plus c. Okay. So this is one of the answers. Or what you can do is, one I can write it as cosecant square x minus cot square x. Okay. So cosecant square x minus cot square x means I can write it as log of cosecant square x minus cot square x. So I'm using this one here. So cosecant square x minus cot square x by cosecant x plus cot x plus c. So what is a square minus b square?
A plus B into A minus B.
A plus b into a minus b divided by cosecant x plus cot x plus c. This and this will get cancelled. So log of mod of cosecant x minus cot x. So this is another formula. You can either use this or use this. You will get the same result. Okay, in the textbook, this is the one which is given, so you can remember this.
Sir, one clarification, sir. Sir, we are using mod here only because log cannot get negative values, right?
That's it. Yeah, that is the reason.
Yes.
Yeah.
Sir,
Yeah.
sir, if we substitute T as cosecant x minus cot x, we directly get this answer, no, sir?
You can get it. Then you should have done the multiplication division with cosecant x minus cot x.
Okay.
But see, you cannot directly substitute as t because see, if you want to substitute cosecant x minus cot x, you would have multiply and divide and see. No, are you getting it? I think you will get it. Yeah, you can still do that also. Both are right. Okay. But the advantage of this method is I followed the similarity with respect to previous method. And secondly, you learned one more formula for the same. So generally what happens with trigonometry is sometimes your answer will not match with the book answer. It is because sometimes if you stop with this, okay, this answer is the same as this. So sometimes in the book, they will give you the last one which I did, but you would have stopped with this. It is just manipulation. So it is an advantage. You can learn both. Okay. So here there is no other doubt, no doubt, no doubt.
No, sir.
No doubt.
Okay. So log of cosecant x minus cot x. Next. Now tell me, example 6. So integral of sine cube x into cos square x. So whenever you have product of sine and cos with different powers, I'm repeating it again, listen to it. So had the question been integral of sine square x into cos square x, then what I would suggest you to do is, you can write it as integral of sine x into cos x the whole square dx. Okay. So wherever you have product of sine and cos with the same angle in between them, you can always try to write it in the form of sine 2x. Are you guys able to understand what I'm trying to say? So had the question been sine square x into cos square x, you can follow this method. This is an idea. Okay, then what I can do is integral of 2 sine x into cos x the whole square divided by 4 into dx. I could have written it like this. Then this will become sine 2x the whole square. Then you could have manipulated it. Okay. But here, if you observe with respect to this question, it is not the same power. They are what? Different powers. So you need to think in terms of substitution method. So what can I do? That is the question. So what can we do? You can substitute one as the derivative of other. So one is the derivative of other, right? Sine is the derivative of cos and cos is the derivative of sine. You think which one you can substitute. You tell me whatever is in your mind, I will just do that. You can make an attempt, do a trial and error basis. Don't look at the solution. You do a trial and error method and see. Let's understand where all we get stuck.
Sir, cos square x is equal to t.
If you substitute cos square x as t, then what do you think will be the derivative of it?
Minus 2 cos
Minus 2
2
cos
cos
x
sin
into
x.
sin x dx. You will get something like this. No, once you have substituted cos square x as t, okay, this will not be there in the question. So your question has got converted to what form? It has got converted to a pure sine function. If you do that, then you will again get a cos. So do you think you can handle it?
2? Oh, okay.
So
No.
taking cos
You're
x
able to
as
understand?
t,
Oh, yes, sir.
Let's, right. So maybe that will not work.
so taking
But
cos x as t,
we'll try that. You want to take cos x as t. Do you think this will logically work? So if you
it
take
is
cos
because
x,
we get only sine.
you get only sine. But let's try to see. But you have to do manipulations. Okay, be ready. So cos x is t means it is going to be minus sine x into dx is equal to dt. Right? This is all I have in my hand. So integral of, so whenever you have a dx, if there is a function associated with it, you need to extract that function from the question itself. In the sense, I have sine cube x. I need only sine x into dx. So sine cube, what modification I need to do?
Sine x
Sine
into
into
sine
sine
square
square
x.
x.
I need to write it as sine square x into sine x. Okay, sine square x into sine x dx. Now what I'm going to do is, instead of cos, I'm leaving the question as it is. Sine square x into sine x into cos square x dx. Now I will substitute everything. So why I did this step is because I got the clarity that I need to split sine cube as sine into sine square only from this step. Okay. So integral of, I have sine square x. I can do nothing about it. Let's think what we can do later. So sine x, I can combine it with dx so that sine x into dx will give me what?
Minus dt.
Minus dt.
Minus dt. That's right.
Minus dt.
Similarly, cos x is there. If I substitute cos x, it gives me a t square and I have a minus dt. I hope it is clear till this step. Now what I have is, I have a sine square. How can I relate sine square to cos? So now your mind should think of the identities.
Root
What
over
can I
1
do?
minus
1 minus cos square
One
x.
minus
That is
cos
sin x.
square
That
x.
is sin x. That is sin x. I have sine square x directly, so I can write it as 1
1
minus.
minus cos square x.
So if
1
I write
minus
it as,
cos.
if I write it as 1 minus cos square x into t square into minus dt, now can I substitute cos square x as t square? Because
Yes,
I know
sir.
cos x is t. Now when you substitute it, how will the function get? So this minus I'm taking it out. So it gets simplified like this: 1 minus t square into dt. Now is it easy for you to solve? So
Yes,
what you
sir.
can do is take this t square and multiply to each term and then proceed. Okay. So can you guys finish and tell me what is the answer?
cos power 5x by 5 plus minus cos cube x
Minus.
by 3 plus c.
That's right. Cos power 5x by 5 plus, sorry, minus cos cube x divided by 3 plus c. Right. So with the hope that you guys can do this further, I'm not doing the thing. Just give me a minute. I'm not solving this problem. So now what I'm going to do is, we will try out another method. Why only like this? Right. What else can we try? Let's understand where we fail. Okay. If we do the other method. So I told you another idea, right? What is it? So alternate. So the question is integral of sine cube x into cos square x dx. Right? Is it necessary that I need to substitute only cos x as t? My mind will question, why don't I substitute sin x as t and try out? Can I try?
Yes, sir.
Yeah, we can do that, right? So you might get this question in your mind. I'll put sin x is equal to t. Then what is it telling me? So it tells me that cos x into dx is equal to dt, right? So if I do this, so cos x into dx is coming. So what should I do?
Splitting of cos square
Cos
x.
x into cos x.
So integral of wherever sin x is there, I'm going to substitute it as t. So t cube into integral of cos square x, I can write as cos x into cos x. So cos x into cos x dx. So this cos x dx will be
dt.
dt.
dt. So it will be integral of t cube into, here what will happen with respect to this cos x? This cos x will be root of 1 minus sin square x
Sin square x.
into dt, right? So it will become integral of t cube into root of 1 minus.
c square.
Square.
Will you be able to solve this? We cannot solve this because you have an algebraic and a square root. You don't know how to approach this. You don't have any direct formula, do you? So you cannot multiply the c cube inside and then proceed. Had the square root not been there, you could have done this. Okay. So what is it you're able to understand from the approach you have? For example, whenever you have a question of sine power mx into cos power nx dx, then which one should you substitute it as t? What is the idea from this problem?
Cos.
Cos.
Cos x as t.
No, it is
The one with the lesser power.
Very good. It is a trigonometric function with a less power. For you to understand this, what you can do is you can try to swap the question and try solving it. Had the question been cos cube x into sin square x, your answer would have been easy. You could have solved it actually. Are you guys able to understand? So make a note of it. So whenever you have a product like this, integral of sine power mx into cos, like how you write in your notes, just put it as an idea, put it in a box. So idea, integral of sine power mx into cos power nx dx. So substitution method is put or consider. So what should I consider? Consider the trigonometric function with
Lesser power.
Lowest power.
lesser power as t and then proceed. Now you guys understood? So you have to try out all the trial and error basis methods. So don't look at the solution and don't get satisfied with one method. So make a note of this. If you're done with this, I will proceed to the next one. Okay. We'll proceed to the next one. Just a minute. See, mark the next one as important. So if you look at the question, integral of sin x divided by sin of x plus a into dx. Here you cannot follow any method. Okay. Here you cannot solve anything. See, for example, I don't have anything like one is the derivative of other. Had the question been like this, sin x divided by cos of x plus a, then my mind would have told me. So had the question been like this, what would you do? By the experience you have currently. So if I have sin x by cos of x plus a, what would your mind tell you?
Cos x plus a equal to t.
You can try cos x plus a is equal to t and then proceed because derivative of cos will be sin. So you would have got some steps, right? But here I have sin in the numerator and the denominator. So I need to think how to eliminate. So integration, what is the main thing? You have to get rid of the denominator. If I need to get rid, what I should do is, I should be able to write the numerator in the form of denominator. Am I right? So what is missing in the numerator that is there in the denominator? If you observe, it is x plus a. So if I need to manipulate it, I can write the numerator as, it is actually sin x plus 0. So I can write it as x plus a minus a. The whole divided by sin of x plus a into dx. Right? So this x plus a, I will treat it as capital A. The small a, I will treat it as capital B. Then what you will get? Integral of sin a cos b minus cos a.
Cos A sin B.
Cos a is what? X plus a
X plus
sin
A,
b.
sin of A.
So whole divided by, I am splitting the sin of x plus a to each term here itself. Right? So this whole thing into dx is going to come. So sin of x plus a and sin of x plus a is gone. So what will I have? So this is one function, this is another function. We know that integral of f of x minus g of x is integral of f of x minus integral of g of x. So it will be cos a into integral of dx minus sin a into integral of cot of x plus a dx. Is there any doubt till this step? Just go through it.
Sir, I didn't understand the last step, sir.
So cos a, I took it out separately, integral of dx. Okay, wait, I'll
Yes,
write.
sir.
Sir, can you explain it again? I had a network issue, sorry.
Okay, no, sure. No issues. So it is integral of cos a into dx minus integral of sin a into cot of x plus a dx. Can I write it like this? Because this whole thing is one function, this whole thing is another function. So I am integrating cos a with respect to x. With respect to x, cos a is constant, so integral of dx minus with respect to x, sin a is a constant, integral of cot of. Now is it clear?
Yes, sir.
Yeah. Cos a into derivative of x is x into sin a into, what is the derivative of cot of x plus a? What is the derivative of cot? This log of
sin x plus C.
Sin of x plus a plus c. That's it, right? Did you guys understand what I did? So it is log of sin of x plus
Yes,
a. If at all you put a in the denominator, that is wrong. Don't do that mistake. When should I put that a in the denominator?
Minus.
No. When x is multiplied with a, not when x is added to a. So what I'm trying to say here is integral of sin x, observe this carefully, integral of sin x is minus cos x plus c. Integral of sin mx is minus cos mx divided by m plus c. Integral of sin of x plus m is minus cos of x plus m only. Why?
Because we are adding m to x, not
You're
multiplying.
adding m, you're not multiplying. Okay. So to understand this better, what you can do is, you can do this as a trial process and see. You can take x plus m as t and then you can proceed and see. You will get the answer as minus cos of x plus m. So have a clarity. Just because a constant is added, don't put an m or a in the denominator. So I've seen that mistake. That is what I'm telling you. Okay, don't do that mistake. So this will be the final answer.
Sir, 1 minute, sir.
Yeah, you can copy it. If there is any doubt, let me know. Done?
Sir,
Yes, sir.
Yeah, tell me.
Sir, if we don't get the idea of taking x plus a and minus a in the numerator, then how should we proceed, sir?
This is the only way. See, idea means you should have this point in your mind. Integration is about eliminating what?
Denominator.
Denominator. So you will get this idea whenever you have the same type of functions in the numerator and denominator.
Oh, okay.
Okay.
Sir.
For example, I have a question like x square divided by x square plus 1 dx. I have a same type of function with the same power. So what I will think is, I will add a 1 here and subtract a 1. You're able to understand. Where did I get that idea from? I didn't put it randomly.
Okay.
I
Okay.
derived the idea only from denominator. So what will happen to the question is 1 minus 1 by x square. You're able to understand this point?
Yes, sir. Yes, I'm able to understand.
So that's the thing. So that is the idea I used. Yeah. So depending on the question only you have to do. For example, I have integral of 1 by 1 plus tan x. So again, I don't have a formula. So integral of 1 divided by 1 plus tan x into dx. So I don't have a formula. But I know that integration, I have to eliminate the denominator. If I need to do that, what do I do? So I can first try to write tan in terms of sine and cos. I'll try that and see. Because in this question, I'm able to see nothing is a derivative of other. You have a constant and tan x. So if I write tan x as 1 plus, sine x by cos x, then what will I get?
Cos x by sin x plus.
So I get something like this. What do I do with this? Will we be able to do anything?
Writing one in terms of the other, sir?
How do you do it? See, suppose, and we'll just discuss the idea. You try now. Suppose if I have like this, what is it telling me? I have cos x dx in the numerator. So derivative of which function is going to give me cos x dx?
Fine.
Obviously,
Sin
sin.
x.
I have sin x here, but what is the problem I will face? If I substitute sin x as t, I will not know how to handle with
Cos x.
then what can I do? Now what you can think is, since I have a tan x, my mind starts thinking about secant square x. Will I be able to bring any secant square x into picture?
No, sir.
No, right? Obviously, we cannot do that. Right? What else can I do?
Writing numerator in terms of denominator, making them equal.
Shall we try that?
Yes, sir.
Yeah, okay. 1 plus tan x minus tan x divided by 1 plus tan x into dx. Okay, if I write it like this. So 1 plus tan x by 1 plus tan x is going to give me 1 dx minus integral of tan x divided by 1 plus tan x into dx. Now, is there anything I can do? Is there anything you can do? So this you can solve. Answer will be x. Here, what will you do?
Nothing we can do, sir.
Again, we'll get stuck. So any other idea? So you understand why you will get stuck?
Yes, sir.
Why?
So we don't
Why
know
will
how
you?
to substitute, where to substitute, sir.
Yeah, you don't know what to substitute. So one thing is, Wherever tan x is there, again I will think like the sin x divided by cos x, 1 plus sin x divided by cos x into dx. Okay, x minus integral of sin x into cos x divided by cos x plus sin x dx. Is there anything we can do? Obviously,
Again, no.
again no. So what can we think? Then what else can we think of? What else can we think of?
So can we multiply by 1 minus tan x and 1 minus tan x? Multiply and
What-
divide by.
Why did you get that idea? Why did you get 1 minus tan x?
So 1 square minus tan x will be in the denominator. Secant square x will come.
1 minus tan square x is not secant square x. 1 plus tan square x is secant square x.
Okay, sir.
Again, you will get stuck. So what we can do is let's try out. See. So what I will think is, I got an idea like this: 1 plus sin x divided by cos x into dx. Okay. Integral of cos x divided by sin x plus cos x into dx. Right. I'm going back to the first method itself. Now, what I told you, I told you in this problem, what is the important point I told you? Whenever you have sin and cos as a combination, right? Especially in the case of integrals, okay? Whenever you have sin and cos as a combination, we know that one is the derivative of other, so we can proceed it in that way. So, keeping that idea in mind, observe what I'm going to do is, I have cos x in the numerator. So, derivative of which function is cos? Obviously, sin. So, if I'm able to make my denominator in the form of sin, I can proceed. Right? So, the idea is, when I taught you maxima minima, do you guys remember this? If I have a sin x plus b cos x, I told you need to divide the numerator and denominator with what? You can write it as a single function of sin and cos. Single function of sin or cos.
Multiplying with root of a square plus b square.
Very good. So you need to multiply and divide it with root of a square plus b square. If you observe this, in this question, what will happen is I have sin x plus cos x. So what is a and b?
1.
1, right? So I will multiply and divide it with root 2. So if I do that, cos x divided by root 2 into 1 by root 2 sin x plus 1 by root 2 cos x into dx. Now I have two options in my hand. 1 by root 2, I can either write it as sin pi by 4 or cos pi by 4. It is up to me. But what will I choose? I will try to write this first 1 by root 2 as cos pi by 4 because I need it in the form of sin of something. Only then if I substitute the denominator as t, I will get the numerator as cos. Are you guys able to understand what I'm trying to do?
Sir.
So 1 by root 2 into cos x dx divided by this 1 by root 2, I'm writing it as sin x into cos pi by 4 plus cos x into sin pi by 4. So 1 by root 2 into integral of cos x dx divided by sin a cos b plus cos a sin b. Sin of
A.
a plus b. Now you have the advantage. What can you do?
Plus
Put
pi by
sin
4.
of x plus, put the whole denominator as t because the derivative of the denominator is going to give you numerator. Now can you proceed? Right. Shall we try out? Is there anyone having till this step? Is there anyone who is not till this step? Okay. Just a minute. So I will put sin of x plus pi by 4 as t. Then what will happen? Cos of x plus pi by 4. Okay.
Sir, your voice is breaking, sir.
Yeah, just a minute. So here I cannot put cos of, observe, I cannot put sin of x plus pi by 4 as t directly because if I differentiate it, what will I get? I get cos of x plus pi by 4 into d. But what is it I have in the numerator? I have only cos x. So what I will do, so first I will put x plus pi by 4 as t. Then what will happen? dx will be equal to dt and x will be equal to t minus pi by 4. Right? So 1 by root 2 into, how will the question get transformed to cos of t minus pi by 4 divided by
Sin t
sin t into dx, I can write it
dt.
as dt. Right? Now again what I will do is, I will think of this thing as z and then proceed. Are you guys able to understand? So that you can try and then, yeah. Or else what you can do is, cos a minus b formula is there, right? So if,
Yes, sir.
if you apply cos a minus b formula, you can do it like the previous problem. So that is 1 by root 2 into integral of cos t into cos pi by 4 plus sin t into sin pi by 4, the whole divided by sin t. So 1 by root 2 into integral of cos pi by 4 will come out. It is 1 by root 2. Okay. So 1 by root 2 into bracket 1 by root 2 into integral of cos t divided by sin t plus 1 by root 2 into integral of sin t divided by sin t. So 1 by root 2 will come out half into integral of cos t dt. What is it? Sorry, cot t dt. Log of sin t
Log of sin.
Log of 90 plus.
t plus c. This is the answer. Again, substitute back t, you will get the answer.
So that should be t by root 2, sir.
Why t by root 2? I have taken this root 2 outside. No? 1 by root 2, I took it
Oh,
outside.
yes,
No?
yes, yes.
Yeah. So what is the answer for this question? Just a minute. So they have added and then subtracted and then proceed. I told you, for trigonometry problems, you will get different answers. Did you guys
Sir,
understand?
can I the previous answer?
Sorry? Can I?
Scroll up, sir.
This one, huh?
No, yes, sir.
Yeah.
Sir? Sir?
Tell me. Yeah.
So from that cos x by sin x plus cos x step, we can also add and subtract sin x in the numerator, and then we can group it, and then we'll also get the answer.
That also I can do. That's what they have done, no? In the method. In the solutions, I think that's what they have done.
Oh, they've added cos x and sin x. I separated everything.
So you added what? You added a sin x?
Sin x and minus sin x.
Okay.
And then cos x minus sin x by cos x plus sin x will become one term.
1 minute. You wrote it as cos x. So numerator is cos x.
Minus sin x by cos x plus sin x.
Okay.
Plus integral sin x by cos x plus sin x.
Okay. After this, what did you do?
After this, cos x plus sin x will become t. So it will be integral
So here you can.
dt
So this
by
will be
t.
log of sin x plus cos x. What did you do with this step?
Sin x, here I added and subtracted cos x.
Then you will get back the question again.
Yeah, so if you take the question as I, so it becomes
and then
2i
you
is equal.
That's right. That's right. Yeah. But if you see, here you got log of sin x plus cos x. Now we would have not got log of sin x plus cos x. I'll tell you what will happen. Guys, I'll explain this method also. So let me know once this is done. So once you substitute t, what will you get? Log of sin of t is what? X plus pi by 4, no? Then you will have 1 by root 2 sin x plus 1 by root 2 cos x, correct? plus t is what? X plus pi by 4 plus c. Did you guys understand what I did here? Guys, please respond. Did you understand what I did? Or is there anyone having a doubt? I just substituted t is equal to x plus pi by 4.
Oh, okay, sir. Got it.
Got it, right?
Yes,
Now,
sir.
what? See, if you observe, this answer and the one given in the book are not the same. You can have a verification.
Yes, sir.
They are not the same. But I'm saying they both are same because I've written a manipulated answer. Observe what I'm going to do is 1 by 2 into log of this 1 by root 2 I can take out common. So 1 by root 2 into what do I have? I have a sin x plus cos x inside, right? Plus x plus pi by 4 plus c is there. Correct? So 1 by 2 into log of log a into b is nothing but log a plus log b. Accepted?
Yes, sir.
So log of sin x plus cos x plus log of 1 by root 2 plus x plus pi by 4 plus c. Now what I'll do is log 1 by root 2 is a constant. It is some number. Pi by 4 is a constant and c is a constant. I'll combine everything. Then I'll write the answer as 1 by 2 into log of sin x plus cos x plus x plus c. Observe, this would have been the answer given in the question.
Sir.
Right?
Yes, sir.
So what I'm trying to say is for trigonometric problems, especially when you're doing indefinite integrals, you will get different answers for different questions. Okay, for the same question, you will get different answers. I'm sorry. For the same question, you might get different answers, but both the answers will be the same. Okay, there's the first thing you need to learn. Because once you look at the answer, you will get confused that your answer is not matching. It's just a manipulated answer. Depends on which step you leave the answer. That is a question. Okay. So you can ask me, how do I know whether in exam which step should I stop with? You stop with. You should actually try to write it in this simplified. Okay. For example, if this question came in the exam, if you write it as sin of x plus pi by 4 plus x plus pi by 4 plus c, also the answer is still accepted because when they correct the paper, okay, generally what happens is after the exam they'll have some paper discussion. In that paper discussion, multiple answers will be taken for questions like this. So you need not worry about what to be taken. But one thing I want you to be clear is you should have a clarity of that the answer is this. I hope you're able to understand. Right? You should have a clarity of it. You will definitely get it through practice test. Initially, it might appear to be complicated, but it is not. Okay. So this is one method. The other method, I don't think I can complete it now. Okay, anyways, I'll do it. I'll try to explain it. Listen. So if we got this thing, right? Cos x divided by sin x plus cos x dx, right? So who was explaining me about adding and subtracting?
So me, sir.
Kritika, right? So I is equal to, if you observe, if at all you want to use the denominator as t, then what should be the numerator? I'm just telling you how to think. If I want to use sin x plus cos x as t, then what should have been in the numerator? Derivative of sin is cos. I have a cos. Derivative of cos is
Sign. Add and subtract a sign in numerator.
Minus 10.
Right. So I have a cos x in the numerator. So I will subtract a sin x and add a sin x divided by sin x plus cos x into dx. Right. So this will become I is equal to integral of cos x minus sin x. You should know which one to be combined. Cos x minus sin x divided by sin x plus cos x into dx plus integral of sin x dx divided by sin x plus cos x. Right. Now, if you substitute this as t, the numerator will be dt. You can do that and see. Then the answer here will become log of sin x plus cos x into dx. Sorry, dx is gone. Plus, here if you observe again, I have sin x. So what you can do is, to get this in the form of denominator, you can add a cos and subtract a cos. So sin x plus cos x minus cos x, the whole divided by sin x plus cos x into dx. Okay, then this will become log of mod of sin x plus cos x plus this sin x plus cos x. I'll combine it with the denominator. You will get a 1. So integral of dx minus I'll get integral of cos x dx divided by sin x plus cos x. Did you understand what I did?
So one doubt.
Yes, sir.
Yeah, tell me.
Sir, after that cos x minus sin x by sin x plus cos x, how did you write, sir, that log of sin x plus cos x?
Because I took sin x plus cos x as t. So if I take that as t, then cos x minus sin x into dx will be equal to dt. So what will happen here? Cos x minus sin x into dx will be dt. So dt divided by sin x plus cos x is t. Its integral is log
Got
t.
it, sir. Yes, log. Yes, sir.
Now you got it?
Yes,
So if
sir.
you observe this thing, cos x divided by sin x plus cos x divided by sin x plus cos x is nothing but I. Okay. So if I write this also as I have this minus I. When this minus I comes to the other side, it will become 2 times I. So 2I is equal to log of sin x plus cos x plus x. Integral of dx is x. So I will be equal to 1 by 2 times this value plus c. So this is another way. I think something similar is what is done in the book also with the same idea. Okay, the idea is still the same. Okay, there is an alternate method. So you can just take a screenshot of this. Okay, just give me 2 minutes time. I'll take the attendance and then you can leave.